So now let's look at a slightly different version of the projectile motion problem. So John kicks a ball with an initial velocity of 10 meters per second and at an angle of 53.1 degrees. We want to know how much time does it take to reach the apex? Well, first we find the y component of the velocity by taking the v initial, the 10 meters per second, times the sine of theta, so 53 degrees, and that gives us 10 times sine 53, which is 8 meters per second. So now we can solve for the time when the y component of the velocity goes to 0, and so that means our v final is equal to v initial plus acceleration times time. So we plug everything in. Our initial is 8 meters per second, acceleration is negative 10, so we see that the time that it takes to reach the apex is 0.8 seconds. So next, and if we want to know the total time, so it takes 0.8 seconds to reach the top, so then it's 0.8 seconds to go from the top to the ground again. So if we want to know the time it takes to hit the ground is going to be 1.6 seconds, twice 0.8. So now we want to find the maximum height. So now we know that the height at any time is equal to the v initial times time plus 1/2 at squared. So that means at this point we have the v initial, that's 8 meters per second, and we want to find it at a time where time is 0.8 seconds. So we plug that in, so it's our 8 meters per second times 0.8 plus 1/2 minus 10 times 0.8 squared. So that means that the height at the apex here is going to be 3.2 meters. So, all right, and so now we want to find the horizontal displacement, so the range. So to do that, we can multiply the time in the air, so that's going to be 1.6 seconds, and we want to multiply that by the x component of the velocity, so that's going to be the v initial, the 10 meters per second, times the cosine of 53 degrees, so that's going to be 6 meters per second. So here are, we can just multiply the average velocity, so the 6 meters per second, times the time, which is 1.6 seconds. So that tells us that it's going to travel 9.6 meters. So I want you to notice something here. So if we break our flight into two pieces, first time to the apex, we know how long it took to reach the apex, the velocity at the apex, and the change in height from the beginning to the apex. So if we wanted, we could now do a horizontal motion problem, but set it to any height that we want. That means we have the tools to solve the situation in which a ball is launched from some height above the ground or below the ground, and we can solve it directly without the quadratic equation. Okay, so we have one more problem left. We want to consider the reverse problem. So now we know that a ball is launched and that it lands 60 meters away after 4 seconds. So we want to find out what happened. Well, our first question is, what's the x component of the velocity? Well, the ball traveled 60 meters horizontally in 4 seconds, and the x direction is constant velocity, so we can just divide the displacement by time to get the velocity. So the displacement is 60 meters, which is equal to the velocity times 4 seconds, so that means that the velocity is going to be 60 by 4, so it's going to be 15 meters per second. So that's our x component of the velocity. Our next question is to find the y component of the velocity. Well, now we know that it takes 4 seconds for the ball to hit the ground, or it takes 2 seconds to reach the apex. Well, if it takes 2 seconds to reach the apex, the final velocity is equal to the initial velocity plus acceleration times time, so the final velocity is 0, our time is 2 seconds, and our acceleration is negative 10, so we can solve for the Vy initial, and that's going to be 20 meters per second. All right, so we just add 20 meters per second squared times 2 seconds to both sides of the formula, and then we've got our 20 meters per second. So for the maximum height, we have the initial velocity in the y direction, 20 meters per second, and that the apex is at 2 seconds. So we can use our second kinematic equation. So delta y is v naught y t plus 1/2 at squared. And so we can plug in for our initial velocity, which is 20 meters per second, add 2 seconds for our time, and then our acceleration is -10. So if we follow through with that, then we find that the maximum height is 20 meters. So lastly, we want to find the muzzle velocity and the angle. So to find the angle, we know the y component of the velocity is 20 meters per second, and the x component is 15 meters per second. So if we take the inverse tangent of y over x, so 20 meters is the meters per second is y, so that becomes inverse tangent of 20 over 15. So that turns out to be 53.1 degrees. For the magnitude, we Pythagorize it, right? So the velocity is going to be the vx component squared plus vy component squared, and take the square root. So we do that, and we find that the velocity, the magnitude of the velocity, is 25 meters per second. So notice this is a nice problem because it sort of makes you go through the thought process of how motion works in the x and y direction, but you're sort of doing it in a different way, so it makes you think about it a bit. All right, so you're going to do a very similar problem here, but you're going to do it with a cannon being fired, but otherwise it's pretty similar. All right, so I think that's it for this week. So you've got one more set of problems to go through, and pretty much just what we just did. All right, good luck, and take care of yourselves.